Alright, taking a quick break from playing dress up with Princess Ada and King Isaac to talk to you for a couple minutes about subtracting radicals. Spoiler alert, subtracting radicals, very similar to adding radicals, very similar to subtracting polynomials. So let's get right to it. Alright, so lesson 115 is subtracting radicals. By the end of this video, 3 things should have occurred. 1, you should be able to subtract radicals, as our learning target suggests. 2, you should realize that subtracting radicals is basically the same as subtracting polynomials, which you did several lessons back. And 3, you should realize that this image is the raddest image ever. Because look how cool it is. It's sad that your copy has to be black and white and not all vibrant and pretty like mine. But at least you have the video to know how awesome it really is. Okay, so let's get into these very, very short notes. Just like when you add radicals, before you subtract, you have to make sure that you have like bases. There's my fancy little pop-up there, so you don't have to read my handwriting. Once you have those like bases, all you have to do is subtract the coefficients. Just like when you add, it's also very similar to when you're working with polynomials. You've got to have those like terms, and then you're just working with your coefficients. So let's get right into some examples. Example 1. First thing I'm doing is looking to make sure that those radicands are already the same. Remember, radicand is the number underneath your radical symbol. So I do have radicands that are already the same there. It both says square root of 3. So this is the easiest example ever. It is just a matter of looking at those coefficients and saying 8 minus 5 leaves me with 3 roots of 3, or 3 root 3 is how it would be read. I could get more complicated and say, okay, remember this 8 root 3 means 8 times root of 3. So I've got 8 little roots of 3 over here. 1, 2, 3, 4, 5, 6, 7, 8. And when I subtract 5 roots of 3, that means I'm taking away 1, 2, 3, 4, 5 of them, which leaves me with 1, 2, 3 roots 3, which we write this way. So let's go to one that's a little bit more complicated. Example 2 does not already have like bases, or the radicands are not the same. So I'm going to start by simplifying this to see if I can make them be the same. So square root of 24, my 24, I'm going to do my prime factorization. 24 splits into 6 and 4. It also splits into other things, obviously, you know, 2 and 12, 8 and 3, whatever you like. 6 is going to split into 2 times 3, and 4 splits into 2 times 2. So what that means is that I have a single pair here. I've got a 2 and a 2. I have another 2 there, but that's not really helpful because it doesn't have anything to pair up with. And I've got a 3 here that doesn't have anything to pair up with. So when I simplify this one, what I've got is I still have that coefficient of 4. So I've got 4 times, remember that I'm going to pull out one of these 2's, so 4 times 2, and then inside I've still got 2 times 3. So inside my radical, I've still got that 6. Over on this one, 10, the prime factorization is 2 times 5. There are no pairs in there, which means there is nothing I can do to simplify that. So when I try and rewrite this, I really can't. It's still going to be left with 3 root 10. So my final answer, my simplified answer, I would have to go ahead and multiply this coefficient by the perfect square that I pulled out. So 4 times 2 is 8. I've still got that root 6 and minus 3 root 10. I can't do that subtraction. So that's my answer. I can't go any farther. All right, let's look down at example 3. Example 3, we have this 3 root 11 minus the square root of 176 minus 11. Well, I know that I'm going to be able to subtract these two. I also know, because they already have like bases, I also know that 11 is a prime number, so that can't be simplified any farther. This middle term here, I'm just not sure about. And also, other than 2, because I know that 6 is divisible by 2, I don't know what this is divisible by. So I'm going to pull my calculator up real quick, and I'm going to see if I can divide this by anything good. What I'd like to divide it by is maybe 11, because it'd be real nice if there was an 11 buried in there somewhere. So I'm going to say 176 divided by 11. And look at there, it's 16. That's brilliant, because what that means is I can say, oops, I can say oops. Yeah, y'all already knew that because I say it all the time. I can say this is 16 times 11. Now, when I simplify this, it's going to go 4 times 4. And if you watched the additional video under simplifying radicals, you know that I'm not going to go any farther than that. Yes, I know that 4 is not prime and that I can go down to 2's, but I also know that 4 times 4, if I put my radical there, is going to be, it's the square root of 4 times 4 is just going to be 4. So I'm stopping there now that I've got some practice and I'm good at simplifying radicals. My root 11 is still here, and then I've still got this 3 root 11, a minus sign, and my minus 11. So all I did was pull these down so that I can finish up my problem. So now, again, I'm looking at my coefficients. I've got 3 minus 4 minus, and this is really important that you remember that, in fact, I'm going to put it in a different color. It's important that you remember that there's a little 1 there. Just like when you have an x and there's no coefficient, you have to remember that there is a coefficient of 1. So I'm going to do this one step at a time. 3 minus 4 is negative 1, and there's still that root 11. You could also just write that as negative root 11. And then minus another root 11, which if it makes you feel better to put a 1 there, you can. So now my coefficients of these two, I've done those two, I've still got this one to deal with. So negative 1 minus 1 is negative 2 root 11. And that's my answer. All right, one more example for you. This one's got some variables mixed in. I thought it'd be good to do an example of that kind. So let's start. Again, I don't have radicands that match up right now, so I'm going to start by simplifying. I see 80 and immediately think 8 times 10. That may or may not be the best route to go, but it's the first thing that popped into my head, so I'm just going to go with it. 8 goes to 2 times 4. I got myself a little 4 there. That's good because I know that's a perfect square. And then 10 goes to 2 times 5. Now, my 4 I'm going to go ahead and highlight because I know that 4 is a perfect square, so I know that that's going to be one of the things that gets to come out of the radical. I've also got this 2 and this 2. So when I rewrite my radicals for this 80, what I'm going to have is square root of 2 times 2, which is just going to be 2, times the square root of 4, which is also going to be 2, times the square root of 5. And remember that we've got that 3x coefficient already there, so that comes down as well. So 3x times square root of 2 times 2 is 2, times the square root of 4 is 2, oops, I forgot my radical on that, times root 5. I'm going to go ahead and multiply 3x times 2 times 2. 3x times 2 is 6x. And 6x times 2 is 12x. All right, so that was a lot of work, but we got there. Now I've got to do my other side. So 125x squared is my radicand. You know what I'm going to do? Well, no, I'm not. Okay. I'm going to go off to the side, and I've got negative 5 root 125x squared. First step, whenever you have numbers and variables in your radicand, I am going to start by splitting those up. Now, x squared, I know that if I go ahead and take the square root of that, I just get x, so I'm going to leave him alone now. 125, though, I've got to split up. It ends in a 5, which means I know that it's divisible by 5. If you're not sure what that is, then you can always come over here and say 125 divided by 5, and you get 25. Now, hopefully you know that 25 is a perfect square. 25 is 5 squared. That means that I can go ahead right now and put my radical and my radical. So the square root of 25 is just 5. The square root of 5 is still there. And the square root of x squared is x. And you know what? I'm going to, just to keep everything nice and neat, I'm going to pull that x down here. So the square root of x is equal to x, and the square root of 20 and the square root of 5 is still under the radical. So my final subtraction problem then, because remember this all stemmed from a subtraction problem, is remember I have this -5 already there as a coefficient. So -5 times 5 is -25x root 5. So my final subtraction problem then is 12x root 5 minus 25x root 5. Whenever you have a problem, this looks really scary, but I have like bases, so I know that my answer is going to be root 5. That x is also a like term, so the x is still going to be there. So the coefficient, the thing I really have to worry about, is 12 minus 25. Well, that is a subtraction problem that gets me -13. Please ignore the heels coming running. That's my daughter playing dress up. But 12 minus 25 is -13. So my final answer is -13 x root 5. Hopefully I didn't make any mistakes there, because I do realize that that was a lot of work. But ultimately it boils down to, we simplify the radical. Once we're done simplifying that radical, we multiply it by the coefficient that was already there. Then we look at our second term, we simplify its radical, and then multiply it by the coefficient that's already there. And then we can do our subtraction. If you have any further questions, please, please, please let us know. We'd love to explain it a bit more for you. Have a great day.